Okay, so this video is going to be on lesson 4, and lesson 4 is on page 227 of your workbook. Just to sort of say where we're going with this, tomorrow, you guys, lessons 5 and 6, and then that means your quiz on Friday will be the first 6 lessons, okay? There are 7 lessons in the TRIG chapter, so it'll be pretty much everything except for that last lesson. So your quiz on Friday, the first 6 lessons. Okay, what lesson 4 was, no, sorry, lesson 3, we were calculating sides of a triangle, right? So we were using trigonometry, SOHCAHTOA to calculate sides. This lesson, we're now going to calculate angles. We're going to use SOHCAHTOA now to calculate the angle of a triangle. So before we do that, let's just do a quick review from, this would have been lesson 2. At the top of your page, write down the sine of angle X is equal to 0.45. Do you remember how to calculate angle X? So this is, I say often, we're going backwards, which is called an inverse function. So how we go backwards on our calculator and how we write it down correctly is we write the inverse sine. So it looks like sine -1, but how you would never read that sine -1. How you would read that is the inverse sine. You must have a bracket here, and you always put, this is a ratio, the ratio goes in the bracket. When we type on our calculators, that inverse button, the second function button, and the ratio, an angle will come out. So make sure you're in degree mode. So everybody type in the sine of 90 degrees. So make sure that your calculator, again, is in degree mode. So some of you came up for homework, and my calculator is always in radian mode for the grade 12s. So I always have to change mine back to degree. So then from here, I could type in the inverse sine of 0.45. So the inverse sine of 0.45. And I would get, if I was rounding to the nearest degree, 27 degrees. So we actually just did this question here. So angle X would be 27 degrees. Can you guys please calculate angle Y for me and angle Z? And then I'll ask 2 different people. So angle Y and angle Z. To the nearest degree. Cade, what did you get for angle Y? 81 degrees is the right answer. Holly, what did you get for angle Z? 79 degrees is correct. Remember, with angles, you must always have the degree symbol. Okay, so let's do class example number 1, and it's going to be slightly different. So we'll start with A, and I'll probably do A and B with you, and then I'll get you to do C. So can you guys please label your triangle for A according to the given angle? Okay, so according to this, that would get the eyeballs. That would be my opposite side. This would be my hypotenuse. By default, this would be the adjacent. We have to box in 2 sides. When we are solving an angle, it's different than we're solving a side. So when we were solving a side, we always boxed in the unknown side, right? And then we boxed in a given side. When you guys are looking for an angle, that is our unknown. So the 2 sides that you must box in have to be given sides. We can only have one thing missing. So what we're missing is the angle. So you have to box in 2 sides. You'd have to pick H, and you would have to pick O. When you're looking for an angle, you always box in two given sides. So then you're going to write your acronym, SOHCAHTOA, and you're going to say, okay, which acronym or which ratio has O and H, and that would be sine. So it would be this guy here. How you would set this up is the sine of your given angle. In this case, they want it to be called angle A, is equal to, sine is O over H. So I look at what I boxed in. O is 4 and H is 6. Then you say to yourself, oh, okay, we're finding an angle. So I need to see this next step for a mark. So this would be a 3-mark question. 1 mark for setting up this. You don't have to draw that arrow like I always do that, but you don't have to. Your second mark would be for saying inverse sine of the ratio is always going to be your second mark for these questions. And then I would say, okay, on my calculator, the inverse sine of 4 divided by 5. Did I type it in wrong? Oh, 4 divided by 6. Did I write 6 or did I write 5? I'll fix that. The inverse sine of 4 divided by 6 is 41.8, and they want this rounded to the nearest degree, so that would be 42 degrees. So what I'm going to do is I'm going to put 42 degrees here. Oh, I see. Here's where I made the mistake. Let me clean that up. This should be a 6. So this would be mark 1. This would be mark 2. And then your last mark and what you box in is angle A is equal to 42 degrees. Let's do B as a class, and then C you'll do on your own. And I'll just pick somebody to give me C. Okay, according to this triangle here, they want angle B. That's the angle that gets eyeballs, and that's the angle that I label from. This would be my opposite side. 19 would be my hypotenuse. 10 would be my adjacent. Because I'm finding an angle, I have to box in two given sides. And the two given sides were A and H. So then I say, okay, which trig ratio has an A and an H? And that would be cosine. So this one right here. So then I would write down the cosine of my given angle. In this case, it's called B, is equal to A over H. So looking at my triangle, that would be 10 over 19, and that's mark 1. Mark 2 would be for realizing that this is an inverse function. So the inverse cos of, so you have to have that cos negative 1 of 10 over 19 is equal to what is that? 58 degrees would be your answer. And then for your last step, angle B is equal to 58 degrees. Can you please do C? So you guys all do C. Oh, actually, yeah. No, let's do C together. This is a good one. Okay, according to this angle, that's our given angle. That doesn't change. I'm going to show you, this is where it gets really interesting. So that's the opposite. That's the hypotenuse. And this would be the adjacent. How many sides did I say you have to box in? 2. It could be any sides you want. So what we're going to do is I'm going to show you something, because this is where it gets, like, students start, when it starts clicking, they like it. Let's pick any 2 sides. As long as we pick the correct ratio, we're going to get the right answer. And then we're going to pick a different 2 sides. So what 2 sides do you guys want me to box in? O and which one? A. Let's do this one. O and A. We haven't done tan yet, so that's a good one to pick. O and A is tan. Okay, so the tan of my given angle, which is angle C, is equal to O over A, which would be 21 over 20. I'm going to skip a step here, and I'm just going to write angle C is equal to, and I'm just going to calculate this. You guys okay with that? So I'm just going to go right on my calculator, inverse tan of 21 divided by 20. So second function, tan 21 divided by 20. Is everybody getting 46 degrees? Okay, so let's box that, and we know that's the answer. Here's what I want you to do. Let's say this was an actual test question. Not all of you might have boxed in O and A. So let's go back up here. Let's unbox this. Tell me two other sides that I could have boxed in. Cohen, what do you think? So he said O and H. Okay, so you guys, I want you to include this work. Just this one more will do. So watch if you did this on a test. O and H. What trig ratio would you use if you boxed those two sides in? Sine. Okay, so let's see. The sine of angle C is equal to O over H, which is 21 over 29. Okay, let's do that on our calculator. So the inverse sine of 21 over 29. What do you notice? Exact same answer. What do you think if a student boxed in A and H, the cosine trig ratio? So we just did tan, we just did sine. What if a student boxed in A and H? They get the exact same answer. So a question like this on a test, sometimes will throw students off because they'll be like, well, what two do I box in? And I can't answer that on a test, right? You have to realize it doesn't matter. As long as you choose two and you pick the correct trig ratio that goes on with the two, okay? Normally, I would give you a few minutes to do these questions. We're just going to go through this, so we're just going to keep going. And we've got 3 examples left. So let's finish off these 3 examples. And then I'll give you all your homework at once. Okay. Please, if you have your highlighters, take them out. Highlight this angle of elevation and highlight angle of depression. Students are really good at trig, I find. And then this is where, if they're going to mess things up, it's going to be here. Okay, so here's what I want you guys to draw. Draw on your page a little stick person with an eyeball. Okay. This person, or imagine me right now looking out at you, I am looking straight. If I elevate my eyes, do I look up or do I look down? Up. Yes. So this person could elevate their eyes. So imagine always looking straight ahead first, and then you're going to either lift your eyes or lower your eyes. So if you lift your eyes, this angle right here, that is what's called the angle of elevation. Okay, so when you're looking straight ahead and then you lift your eyes, that's the angle of elevation. Draw another head with an eyeball. And you always start by looking straight ahead, and then you could depress your eyes. If you depress your eyes, where are you looking? Down. This angle here is what we call the angle of depression. What is key to this? So the key thing where students are going to mess this up, it is always measured from what's called the horizontal. So whether we're doing the angle of depression or angle of elevation, it's always measured from the horizontal. What the horizontal is, it's this line here. You always have to say to yourself, where's the horizontal line? And this would be the horizontal line. Okay? So just to sort of show you, here's a ship. People are on the ship. This would be the horizontal line. And then they could raise their eyes to the helicopter. That would be the angle of elevation. Okay? The helicopter stares straight ahead. That's the horizontal. Or the pilot could stare down at the ship. That would be the angle of depression. What happens is I'll give students a triangle, like two triangles like this, and I will say, so from this ship, I'll say, where's the angle of elevation? And let's say I say, you guys, the angle of elevation is 30 degrees. Can you put in where you think in this diagram 30 degrees would go? So it labels it for us. And it labels it right here. The mistake that students make on a test is they like saying this is 30 degrees. But here's the thing. It always has to be measured from the horizontal. That is not a horizontal line. That's a vertical line. So if I said for this question that the angle of elevation is from the ship is 30 degrees, you would say, okay, there is the horizontal line. There is my slanted line. This guy would be 30 degrees. Then what is super important is this. The angle of elevation is equal to the angle of depression. So if I tell you that this is 30 degrees, then automatically you find the angle of depression, and it's going to make a Z, either a regular Z or a backwards Z. So the Z would be right here. That's the Z. So it's got both horizontal lines in the Z. The angle of elevation, which is right here, it is equal to that angle there. Okay, so I only have to give you one angle, and the angle of elevation is always equal to the angle of depression. All right, let's see if we could do this. Class example number 2. A tree is 5.1 meters tall. Can you guys put the 5.1 meters in there? So 5.1 meters should be right here. It casts a shadow. So remember, the students in the video wouldn't have heard this, but shadows are always on the ground, right? So don't ever say that your shadow is this hypotenuse. Shadows always fall on the ground. When you measure a shadow, your shadow falls on the ground, and then somebody could measure how the length of your shadow. So it says the shadow is 7.5 meters long. Calculate the angle of elevation of the sun. So basically this is going to make a triangle, and then the sun's going to be like back here somewhere, and the angle of elevation is always measured from the horizontal, so it would be that angle there. That is our angle X. That's what they're looking for. So let's give that angle a set of eyeballs and label this guy. So opposite, here's my 90 degree. So hypotenuse and adjacent. Jack, what two sides do you want me to box in? Yep, opposite and adjacent. Lucas S., what trig ratio do I use that has O and A? Is it SO, CA, or TOA? It is TOA. So the tan of my given angle, which happens to be angle X, tan is O over A, which would be 5.1 over 7.5. For a word problem like this, 3 marks. Second mark is for saying the inverse tan. In a bracket, you always put the ratio, and it should be 5.1 over 7.5 is equal to. Okay, so that would be 30, they want this to the nearest tenth of a degree, so 34.2 degrees. And then I would say angle X is equal to 34.2 degrees. This one, star this guy. A boat is 130 meters from the base of a cliff. The cliff is 80 meters high. Okay, so let's draw like this. Whoops, I don't know what that is. Okay, here's our boat here. Okay, so this is our cliff, and this is the boat. The boat is 130 meters from the base of the cliff. So I'm going to put 130 meters here, and the cliff is 80 meters high. That would go there. I don't often put units on my diagrams, right? Not needed. Draw a diagram to represent this scenario and mark the angle of depression of the boat from the top of the cliff. Students have a hard time with this. So watch this. We know that this is the triangle here. So imagine that somebody is standing at the top of the cliff looking down at the boat. Put an X where you think the angle of depression is. So imagine somebody is staring down at the boat, but should you always stare first? Yeah, the horizontal. So there's like a set of eyeballs up there, and they can stare straight ahead. They could elevate their eyes, or they could stare down. So if you put your X here, you'd be incorrect. And a lot of students will do that on the test. The angle of depression is actually this guy right here. How many of you get that? Okay. So it always, you guys, the key is this, from the horizontal. Right? That's the key. If you put your X in here, that's not a horizontal line, and that's not a horizontal line, right? There's no horizontal line in there. So that is not the angle of depression. So I'm going to get rid of that, get rid of that. The horizontal is this guy to here. Make your Z. Find your Z. So we're going from here, down, and across. Once you have your Z, the angle of depression is equal to what? The angle of elevation. So if this is X, do you guys know where in the triangle X would go? It would go down here. If this is the angle of depression, it's going to make a Z, right? Two horizontal lines, that's my Z. The angle of depression is equal to the angle of elevation. Okay? Let's see what they're asking for. So that would be my scenario. Determine to the nearest degree the angle of depression. So the angle of depression, I'm not even going to calculate it because here's my triangle right here. I'm just going to calculate the angle of elevation because I know that these two are equal. So according to my triangle that I was given, 80 degrees would be my opposite. There's my 90-degree angle. So this would be my hypotenuse, and 130 would be my adjacent. You would have to box in your opposite and your adjacent sides. And then O and A, which trig ratio? Not sine. Sine is O and H. Which one? Tan. Tan. So the tan of angle X is equal to O over A, which is 80 over 130. This would be a 3-mark question. Actually, for B would be 3 marks. This picture would be 3 marks as well. The inverse tan of 80 over 130 is equal to To the nearest degree, what did you get, Alexa? 32 degrees. So angle X is equal to 32 degrees. And then often you guys, for trig questions, you're going to attach a sentence to it. And this one said, like, they wanted the angle of depression. So this is 32 degrees, therefore this is 32 degrees. And then you would just say it at the very end, the angle of depression is 32 degrees. Because, like I said, this answer up there would be 32 degrees as well. Are we good with that? Cohen, yes. No. No boats necessary. Triangles only. Last question. Piper, yes. So for an angle of depression elevation question like this, Piper, you always want to have like that horizontal line. Yeah, you'd want to draw that. Students I find on a test, what they'll often do is they'll take a highlighter in for this and they will highlight that Z is what they'll do. They'll highlight the Z and then this guy is equal to that guy. Okay? Isosceles triangles. Do you know what an isosceles triangle is? An isosceles triangle, it is a triangle with two equal sides and two equal angles. Students will sometimes say, like, how do you remember isosceles? And like, I saw with two eyes, right? Two angles and two sides. So you see with two eyes, there's two angles and two sides. So what happens with an isosceles triangle? So let's just draw a triangle over here. What they will say is like this side is equal to that side. So they'll show it with hatch marks, right? And they'll say, they'll put two hatch marks here and two hatch marks here. And then they'll do something like this. This angle is equal to this angle. So they'll draw like hatch marks in the angle to tell you that the two sides and the two angles are equal. If, for example, I told you guys that this is an isosceles triangle, and if I said that this was 30 degrees, and this is 30 degrees, right? Because if it's isosceles, so these two would be the same. These two would be the same. Do you know how to calculate what this would be? What would it be? 180 minus what? Minus 60. It'd be 180 minus 30 minus 30. So that would be how many degrees? 120. So we're going to need to know that for this next question. Okay, consider the isosceles triangle KLM, so KLM, in which KL is 20 centimeters. So could you put KL being 20? LM is 20. So KL is 20. LM is 20. So the two sides that were equal were those two sides. If those are the two sides that are equal, this angle and this angle will be equal. And then they say KM is equal to 30. So this guy is 30. Why can we not use SOHCAHTOA in the triangle to determine the measure of KLM? So let's find where KLM is, and then I'll ask the question. So KLM, if I was tracing, K to L to M would be this guy here. Why can I not use SOHCAHTOA to figure out how big this angle is? Who wants to answer? Only one hand? Two people? Piper, Owen, Holly, what's the answer? Not necessarily, because I could say like, this is my opposite. I only need two sides to get an angle, and they gave me three sides. I have enough. Oh, and you want to try? You don't got a right angle. So the reason why we can't use SOHCAHTOA is SOHCAHTOA can exclusively only be used for right angle triangles. We don't have a right angle, or at least yet. I'm going to erase this X Do you know how I would create a right angle? What would I do, Cohen? Draw a line right down the middle. If you do that, you've just created yourself two right angle triangles. Now what I'm going to do is I'm going to just draw one of the triangles. So let's just draw this guy here. They told me that this was 20. What would this bottom be now? 15. If I split this guy in half, the half of 30 is 15. So this is 15. This has to be a 90 degree if I'm making a right angle triangle. They wanted this angle up here. So I'm going to put my X here. Okay, that's what they want. Now, you guys, let's say we get that this is 30 degrees. What would this entire thing be? 60 degrees. Yeah, whatever answer we get, we're going to multiply that number by 2, and then we got our answer. So let's do that. Give angle X a set of eyeballs and say that that's the opposite side. That's the hypotenuse, and this is the adjacent. Okay, from here, what do you want me to box in? O and H. Which trig ratio? Sine of my given angle, which is called angle X. Sine is O over H. 15 over 20. We're finding an angle, so this is an inverse function. The inverse sine of 15 over 20 is equal to and they want this. Okay, do not round here. In math, we round at the end. So I'm going to write down angle X is 58.5903. Oh, you know what I'll do? I'm going to do this. 59 dot dot dot. Okay, that's what angle X is. Oh, 48. Is that what you guys are saying? You are right. 48 is correct. Okay, and what they want, so okay, so they wanted, you guys, what is this angle going to be called at the end of the day? L. Yeah, we could say, where do they say it here? Yes, we could say one of two things. We could say angle KLM, or it's the middle one, which is L. So I'm just going to write it like this. I'm going to write the angle symbol, so that's a symbol for angle. So the angle L is equal to, I'm going to take that answer on my calculator, it's already there, and I'm just going to multiply it by 2. And your answer to the nearest degree would be 97 degrees. Angle L is 97 degrees. Okay, we're going to star some, or we're going to circle the homework from, okay, so from the previous part, like if I would have paused this, it would have been numbers 1 to 5. So if you guys could circle 1 to 5. So open up your books 1 to 5. 6, 7, 10, 11, and 13. And story number 12. Number 12 is the another angle of elevation depression. So when I give you your quiz on Friday, I'm just going to pick one question you've already done for angle of depression elevation. That's what you're getting on your quiz. Okay, now that that's circled, let's look at number 10 because it's a really odd triangle. So let's look at number 10 and number 11. So number 10, it's like the Leaning Tower of Pisa or something. Yes. Okay, the Leaning Tower of Pisa is a building in Italy which leans due to the instability of the ground underneath. What do they want us to find? The angle of the lean. Do you guys know? Okay, so here's my 90 degree. What I'm going to draw is because it's really like a squished triangle. And I'm just going to tell you what it is. On a test, you would clearly know. The angle of the lean, it's leaning from the ground here. So the angle of the lean would be this guy here. They want this to be 5.03 and the hypotenuse. So it's kind of like they want that 55.23 to be right here. Okay. Um, yeah, and then you have enough information to calculate what the angle of the lean, like how many degrees is it leaning? And then the other one, what did I say I need to set up? Number 11? Just let me have a quick look. There's one that's weird. Okay, so I'll quickly set up 11. Okay, stairs. So stairs like can make a triangle. So like, yes, you would walk on here and then your next stair would be up here. But it says a set of stairs has a vertical rise of 15 centimeters. So what's the vertical line on this triangle? So like if you have a set of stairs, the vertical is the up and down. So 15 centimeters would go here for every 28 centimeter horizontal run. So they're just doing like a rise over a run. But if that's the rise, this guy would be the run. 28 centimeters. This would be our 90-degree stair. And then the angle between the stair and the floor would be this angle here. Okay, so that's the floor that you step on. And then this would be the angle between the floor and the stair. And you have enough information to finish off this work.